What's up everybody, this is Greg Newberry with another math tutoring video for you. This time we're going to jump into a full cumulative review of Algebra 1. To keep up along with this lesson, there's going to be a link down below to download the worksheet, and we're just going to run it off the PDF. And then if you have questions or anything, go ahead and leave those in the comments below and I'll get to those. If you want to go ahead and skip ahead to the exciting parts, there's a table of contents down below with general headers and some timestamps you can click into. If this is your first time on the channel, go ahead and hit that subscribe button right there. That's going to let you get notified whenever we post new videos. And also, if you get any value out of this, if at any point you learn something, go ahead and smash that like button that's right next to the subscribe. And that's going to help us making content like this that you can enjoy. Now, without further ado, let's jump into the worksheet. All right, so to kick things off, we've got a couple word problems where we're asked to identify the independent and dependent variables in the question. So number one says, Philip enjoys rock climbing on the weekends. At some of the less challenging locations, he can climb upwards of 12 feet per minute. So in this case, the number of feet that he's able to climb depends on the number of minutes that he's able to do so. We're gonna put feet over here and then time on the x-axis. So this would be in minutes. So if we had 1, 2, 3, then the number of feet corresponding to that would be 12, 24, 36. So he would climb, just create some points here on the graph, he would climb in a linear manner, kind of like that, where if we wanted to write this out as a slope function, we could say y equals mx plus b, where if he was starting at 0, let's say, then we would simply be y equals 12x, since he's climbing 12 feet per minute. And that's kind of the greater question again here, is especially when it comes time to graph these functions, do you understand which one goes on which axis and why? So let's look at another question just like that one. This is number 2, and it says that Jose prefers to walk to work when the weather is nice. He walks the 1.5 miles to work at a speed of about 3 miles per hour. So we can understand at this point that Jose walks a fixed linear amount of 1.5 miles at a rate of 3 miles per hour. Again, this would lend itself to kind of a graph scenario where, let's say, y-axis, distance from home. And if we're starting at home, then this graph would start at 0. And then on the x-axis, we would have, of course, time, since Jose's stated rate of travel is 3 miles per hour. So that's per unit of time. And just like last time, if we start with our units 1, 2, 3, I guess, for continuity. If we then label the y-axis as how far has he from home, well, after 1 hour, he would be 3 miles from home, since he's traveling 3 miles per hour. So the rest of this graph would look 3, 6, 9 miles. And obviously that's a bit out of context here for this question, since we are only given that he has 1.5 miles walk to work. So at that point, let's just zoom way in here and let's go into a different color. Let's use red here. So if we know that the y-axis is telling us how far from home, then work must be at that 1.5 mile mark. So this will be that 1.5 mile mark. Then the next question to consider is, how long does that take? Well, we were stated that he was traveling at 3 miles per hour. So in 1 hour, he travels 3 miles. We only need to go 1.5 miles, which is half of 3. So it makes sense that it would take Jose half an hour to walk to work. Just for clarity here, you could also say that this axis here would just be how far he's traveled, or just how far away from home Jose is gone. All right, moving on to number 3, we have Gavin works for a skydiving company and customers pay him $200 per jump to tandem skydive with him. So maybe you could start to phrase the independent variable as Gavin's pay, which is a product of how many tandem skydives Gavin does. So on the x-axis, we would have the number of dives, and then we would be able to mark off 200, and then if he did 2, he'd have 400, and then we'd have a straight line. Whoops, that was awful. Then we'd have a straight line just like that. So again, Gavin's pay would depend on the number of jumps he did, which would lead us to a graphing with these two labels on the XY axis. Next question, number 4, asks us about using the vertical line test. So vertical line test, if you remember, is just whether or not a vertical line intercepts a graph at more than one point. Like if I draw a graph with a squiggly line like this, then obviously we do not pass the vertical line test. As opposed to something like this, which does pass the vertical line test, since at no point does the line intercept through at more than one point. Now let's just sketch those graphs and see, obviously, if they pass. So we have 4, looks a bit like that. At number 5 is a circle centered about the origin, roughly, or maybe. And then we'll just take a red line here and we'll obviously cross off the circle. Obviously that one's not going to fly, but you should be able to identify this as a third degree trinomial, third degree polynomial rather. And you can see that even at this point here, it's not going to intercept more than one time. So number 6 asks us to choose the graph that represents each function, and it's going to be a multiple choice graph A, B, or C. So this one says f of x equals 2/3 x plus 2. So right away we can tell that this is a linear function because it has that mx plus b form to it. Where in this case m equals 2/3. Now I want to look at that for a second because our graph is going to look something like a straight line because we have a fixed slope. Anytime you have a fixed slope, that lends itself to a straight line, i.e. not a quadratic, not a cubic, not a logarithmic or an exponential function where it has a changing slope. If it has the same slope, then it is a line, and that's why the word line is in the word linear. So that should help you remember what type of graph these are going to produce. So if we look at our answer choices, then we can see obviously that graph B needs to be eliminated because it is not a fixed slope. Then if we look a little bit closer to the slope and what the number is, it's positive 2/3. And I emphasize the word positive here because we know what a positive slope looks like versus a negative one. So we know that a positive slope is an increasing line, which is why I've drawn it like that here, going from the lower left relatively to the upper right. And it is indeed graph A because that's the only one with a positive fixed slope. And this may seem like a long period of time to review this question, but in an actual test taking scenario, a question like this may take a couple seconds if you know what you're looking for, versus trying to count blocks and calculate the slope. I don't think that's the best way to approach a question like this. Your time is much better spent eliminating your way from even having to process what that graph C was in the first place. Is it a slope of 2/3, negative 2/3? Maybe, but we were able to save time and increase our accuracy by working our way around even processing these other graphs. So moving on to number 7, we'll use a similar technique. Really for all of these courses, that's something that I've always tried to hold close, is the ability to eliminate the wrong answer. I think is oftentimes really undervalued approach to questions in math, simply because we're most often tested in a multiple choice type scenario, at least through grade school. And I think as far as teaching mathematics goes, that elimination of the wrong answers is a really great way to start guessing more efficiently and more accurately throughout your test taking process. And we can make great improvement over many marginal improvements, of which this can be one. So moving on to number 7, we can see that we have f of x equals negative x squared plus 4. Right away, we should recognize this as a quadratic function because of this x squared term here. We know what a quadratic looks like because we've seen this a million times, hopefully by now, in Algebra 1 and certainly beyond. So we should be able to quickly scan the graphs here and eliminate A and B, leaving us with graph C, the only quadratic function. Now, I'll interject here and say that if this were a positive x squared, obviously then the answer would be incorrect. But if we were given multiple answers that had quadratic shape, I would then begin to simply look at the direction of the quadratic and maybe be able to eliminate my way to the answer, versus trying to figure out which one has been transformed, which way 4 units to the left. I think you're really kind of setting yourself up for a lot of extra work if that's the way you approach a question like this, versus just getting to the clean-cut standard form characteristics of the graph that you're looking for. And that'll serve us well as we venture into harder questions that have more than 3 answer choices, and certainly into honors classes and things where the questions are written much more challenging. These questions here are just kind of a general review for everyone, and I think that everyone would be well served to either take their time and get 100 on this, or for an honors student, I would expect someone to fly through this test and get 100 on it. All right, real quick, we're gonna pause it right there. Once again, if it's your first time here, go ahead and hit that subscribe button right there. That's gonna keep you up to date when we post new videos. Also, hit that like button if you're getting value out of this, if this is helping you understand things. Hit that button. It will make this video more popular, and it will encourage the creation of other content just like this. So that's gonna wrap it up for part 1. Go ahead and click right here, or maybe over here somewhere, and we'll have part 2 linked up so you can keep going. All right, guys, good luck. We'll see you guys in the next one.